All right. 2017 question 1. Let's start. 2017 question 1, and this is from the functions topic. What is the gradient of this line? That's nice and easy. Just make it in terms of y equals mx plus b. And then you should be able to find your gradient. So 3y equals negative 2x minus 4. Y equals negative 2/3 x minus 4. 2 over 3. Answer's A. Any questions there? 2017, question 3. Question 3 and 5, exponentials and log functions. So 3 and 5. All right. What is the derivative of ex squared? Okay, answer is quite simply 2x ex squared. We agree with that. 2x, differentiate the power, and then leave the exponential the same. Easy. Next one. Number 5. Question 5, 2017 HSC. It is given that log A equals log B minus log C. Which statement is true? Okay, when you see a question like that, you've got to think of your log laws. So log A equals log B over C. And then from there, you would exponential everything, so you're left with A equals B on C. Answer is B. Anyone need more work on logs? They weren't able to do that? Or didn't think like that? Okay, moving on. Am I going too fast? Can someone let me know if I'm going too fast? No, going good speed then. Okay, number 5 out. Next one's number 7. Number 7. Which expression is equivalent to tan theta plus cot theta? Which expression is equivalent to tan theta plus cot theta? All right, you can see they've got secs and cosecs and then 2's and 1's, so the best thing is to change this to sines and causes. So tan theta is sine theta on cos theta plus cos theta on sine theta. At this stage you would cross multiply. Sine squared plus cos squared is 1. And 1 over cos is sec, 1 over sine is cosec. Answer is B. Any questions there? Okay, number 7, and we're going to number 10. So you can already tell 1, 2, 3, 4, 5 out of the 10 multiple choice were year 11. Wait, is that question 10? Question 17, calculus. Okay, yeah, I guess so. Yep. The particle is moving in a straight line. The particle is moving along a straight line. The graph shows the velocity v of the particle. How many times does the particle change direction? How many times does the particle change direction? All right, how do we do that? Anyone know the idea of changing direction? What happens? All right, well, let's think about it in terms of parabola maybe. I've got a parabola, let's say that was x and t. When does it change time? Well, what's happening? Well, here the gradient's decreasing. That's at 0, as we know, and that's increasing. So if I differentiated this, we know the velocity curve would look like this. Something along those lines. That'll be the velocity in red with respect to time. So you can tell that it's changing direction from, I guess, decreasing to increasing when your intercepts, when your stationary points are changing direction, so they become your intercepts. So essentially, you're changing direction whenever your velocity equals to 0, right? Because you're changing from, again, decreasing to increasing. How many times does the velocity equal to 0? How many times? You gotta be careful. Say that again.
Is it 3 times?
Yeah, why'd you say 3 and not 2?
There's 3 stationary points.
Ah, right. No. So this was X. X was in that maroony color. V is in this red color. We worked out that every time it changes direction, it's occurring at the stationary point of your X's. So for your V's, when do your stationary points occur? When V equals to 0. When your red curve equals to 0, that's where your stationary points occur. Does that make sense, Tiana?
Yeah.
You don't have X, so you can't be looking at stationary points because you don't have X. You have the red curve. For the red curve, you want to find when V equals 0. Where does V equal to 0? And then again, how many times does that happen? Now the answer is actually 3. Can anyone tell me why it's 3? Not because of stationarity. When or where does V equal to 0 3 times? How does that happen? I'll give you one. There's one. Anybody identify the other 2?
When there's a point of inflection?
When there's a point of inflection. No.
When it cuts the x-axis.
When it cuts the x-axis there. Okay, isn't this another one?
It's parabolic.
Sorry?
Isn't that parabolic?
Yeah, which means what?
It has 2 solutions.
Yeah, this has 2 solutions, this has 1 solution. So the fact that this bounces, there's 2 answers. The fact that this cuts through, there's 1 answer. So in fact, it changes direction 3 times. 1, 2, and then 3. Does that make sense, Diana?
Yeah, I remember learning this now.
2 solutions there. It's just like you saying your normal parabola, I know it's cutting out, let's just say that was -1. If that bounced, do you know what the equation of this parabola actually is? X plus 1 squared. Now, how many solutions, how many times does it actually touch? It only touches it once, right? But how many solutions do you have? You technically have 2 solutions, which is at -1 and -1. So you can't technically say but there's only the one time there. It bounces, so therefore there's meant to be two solutions. That's okay. That's why it's a question 10, a little bit harder. Anybody not understand something that I've said there? Okay, okay. 2017. The next one we're up to is question 11s. Okay, I think we can do all this. This is easy. A, rationalize root 5 plus 1. That becomes 2 root 5 plus 2 on 5 minus 1. I'll go back to that 11E, 11G again. All right, any questions there? Okay, moving down. Next one. In the diagram, OAB is a sector of the circle with center O and radius of 6. Find the exact value of the area of the triangle OAB. Okay, can somebody give me the formula to find this? Area of a triangle. Anyone?
Is that half AB sine C?
Half AB sine 30. And then plug that into your calculator. It can give you an answer. Let's see. Sine 30 should be a half. Nine centimeters squared. Find the exact value of the area of the shaded segment. Okay. Again, can somebody give me the answer? The area of my sector. What's the formula for the area of a sector? Half r squared theta. Half r squared theta. That becomes pi over 6. Six and 6 will cancel out. That becomes 3 pi. Half times 6 is 3. 3 pi minus 9. Minus area of your triangle. Okay, questions? Aya, you're finding that okay?
Yeah,
Did you forget the area of sectors?
I forgot area of sectors.
Yeah. Yeah. Half r squared theta. Okay. All good? Moving on. Next one. G and H. G and H. I'll leave it with you guys for a minute. Okay, my turn. 3x minus 1 equals 2. 3x minus 1 equals minus 2. 3x equals 3. X equals to 1. 3x equals minus 2 plus 1 is minus 1. X equals to minus 1 over 3. Find the domain of the function. The domain needs to occur when 3 minus x is greater than or equal to 0. And that's just pretty much minus x greater than or equal to negative 3 when x is smaller than or equal to. Be careful with that inequality change right there. X is less than or equal to 3. Any questions for G or H? Nope. Okay, and G and H and E did. Alright, so we're up to 12. 12A and 12E. 12A and 12E. Alright, wait. Everyone's okay with those? I didn't hear anything, so I'm moving on. Fine, 12A. Find the equation of the tangent at that point. Again, I'll leave it with you for a minute. Differentiate, sub in the point, y minus y1. Alright, find the equation of the tangent, here we go. Y dash equals 2x plus 4. Gradient for tangent equals 2 bracket 1 plus 4, which equals to 6. Y minus y1 equals m, x minus x1. 6x minus 6 minus 2 is minus 8. Any questions there? E 12E. All right, probability. A spinner is marked with the numbers 1, 2, 3, 4, and 5 when it is spun. Each of the 5 numbers is equally likely to occur. Okay, the spinner is spun 3 times. What is the probability that an even number occurs on the first spin? Even number occurs on the first spin, that's just a simple 2 out of 5. So probability of even equals 2 out of 5. What is the probability that an even number occurs on at least one of the 3 spins? Anyone guide me through what they're thinking of when they say at least one of the 3 spins? Probably an even number occurs on at least one.
Like so 1 and then 2 and then 3, or 2 up to 2.
Yeah, but the problem is when you're saying at least one, that means it could be, yeah, like because you're doing you're spinning it 3 times as well. Spin 1.
So probability of none.
So yeah, that's better, right? If you did,
Yeah.
you got to do it like that, 1, 2, and 3. You're doing okay. So that means it could have been the first one, or it could have been the second one, or it could have been the third one, or it could have been the first one and second one, or it could have been the first one and third one, or it could have been the second one and third one, or it could have been the first, second, and third.
Yeah.
Yeah, you're not going to do that. That's what you've got to understand when you're going to try it that way. You're like, whoa, there's just way too many. So 1 minus probability of all odd. Then that would mean you're going to get at least an even number in one of the three spins. So 1 minus, well, the first ones to be odd is obviously going to be 3 out of 5. The second one to be odd, 3 out of 5. The third one to be odd, 3 out of 5. And power of 3, and so the cube 1 minus that gives you 0.784. Everyone's okay with that? Okay. Triple wide. What is the probability that an even number occurs on the first spin and an odd number occurs on the second and third spins? Very easy. First spin, 2 out of 5, and then odd in the second and third. So 3 out of 5 and 3 out of 5. 2 times 3 times 3, 18 out of 125. If that simplifies. Yep, well good. What is the probability that an even number occurs on exactly one of the three spins? All right. What is the probability that an even number occurs on exactly one of the three spins? So, thoughts, Aya, since you were doing it already, what's the idea? What's your thoughts? Exactly one of the three spins. So what's your thought process for that one?
I don't know if what I'm thinking is right.
Tell me.
Is it the thing where like you do the probability of all the cases multiplied by
Yes.
the probability of so like what you want, and then the times the probability of the leftovers? Is it that?
I guess so. But can you tell me the three different cases? So wouldn't it be like this? The first case would be you get it right the first time, even number, and then odd, odd.
Yeah.
Or you get the first one odd, but then even, and then odd. Or
odd even.
yeah, which I'm sure some of you guys could see. So that's the way I would usually tell you to do it. But now that you start to realize them, you could have just done the first one times by 3 because they're the same numbers. That's it. Yeah, it's better to do it like cases like that. Don't worry about the math. Just think of it in terms of case. So if you want exactly one of the three spins, the first one, then no more. The first one, no. Second one, yes. The third one, no. The first two, no. The third one, yes.
I think I just realized that I was getting confused. I think I was getting at least one and exactly one confused.
Yep. It's okay. It's okay. All right, moving on. Okay, moving on. We're up to 13C, A. All right, so A and C. Question 13A. Okay, use the cosine rule to find x. All right. So cosine rule is 13 squared equals a squared plus b squared minus 2 times a times b times cos c. All right, I'll give you guys a minute again from here, expand and see if you can get out ax. My turn. 169 equals x squared plus 8x plus 16 plus x squared minus 8x plus 16 minus cos 60 is half, actually. Half times 2 is 1. Then that becomes a difference of two squares, just so we don't have to do it any longer. There needs to be. Expand x squared plus x squared plus x squared is 2x squared minus x squared is just 1x squared. 8x minus 8x is gone. And you're left with 16 plus 16 plus 16, which is 48, equals 169. And then it's fairly easy after that. X equals 2, 11. Any questions for me there? Nope. That's okay. All right. And the next one was 13C. Letting m equals to t to the third, or otherwise solve this. We'll go with you for a second. Okay. Just let something in m should become a quadratic. All right, so if m equals t to the third, that becomes m squared plus m minus 6. Factorize m plus 3, m minus 2. You end up with m equals to negative 3, m equals positive 2. You've got to bring back your m as a t to the third equals negative 3, and t to the third equals positive 2. How do I get rid of the third? You would cube it. So cube everything. Cube. That becomes t equals negative 27, or t equals to positive 8. Any questions there? No? Let's do the replacement questions. Okay. Question 2. All right. Similar to what we just said with the double root. The function y equals 1 minus x, x plus 1, x minus 2 squared is 2 graphs. Which of these is the graph of the function? Okay. The first step for these questions was to have a look at the whole polynomial. So what's the power of the whole polynomial? Power of whole polynomial. So the power is 2 plus 1 plus 1. So the whole power of the whole polynomial is 4. But is it a positive 4 or negative 4? Well, that would give you x squared, multiplied by x would give you x cubed, but multiplied by negative x would give you negative x to the 4. So negative, and then negative technically x to the 4 is the power of the whole polynomial. We know that, if you remember, even start up here, odd start down here. So because x squared or x to the 4, I would have started up here. X cubed, x to the 5, 7, start down here. But if it's negative, you do the opposite. So for negative, it would have been the opposite. Not there, I shouldn't confuse you. Opposite way around. So this would be negative odd, and this would have been negative even. That was step 1. So for this question, we definitely know, just by that, the answer has to be C. Has to be C. But we're going to check it anyways. Then the second part of our working out would have been each individual term. Individually, this cuts through, cuts, and it's bouncy. So at 2, it's bouncy. At -1, it cuts, and at 1, it cuts. At -1, it cuts. At 1, it cuts, and it bounces at 2. So it can't obviously be A or D. The only one that it looks like is either B or C. But as I said, x negative x to the 4, they start down at the bottom, so the answer is C. Who needs more work on that? Nope, that was a good refresher. Okay, no questions? Okay. Question 6. On any given day, the number x of phone messages that Ella receives as she commutes to and from work is a random variable with a probability distribution given in the table below. What is the mean of x? Okay, the formula for the mean of x with discrete probability was just the sum of x times the probability of x. So 0 times 0.2 plus 1 times 0.3 plus 2 times 0.2 plus 3 times 0.15 plus 4 times 0.1 plus 5 times 0.05. That should give you 1.8. Since we're here, I'm also going to do the variance. Variance was sum of x squared minus pretty much your mean squared. So the way you did variance was you would have done 0 squared times 0.2 plus 1 squared times 0.3, 2 squared, 3 squared, 4 squared, 5 squared, minus whatever you just found, which was 1.8 squared. And to find the standard deviation, it was the square root of the variance. Okay. Questions there? Excuse me. That's all right. Okay. Should I move on? Yep. All right. Question 12. 12B and 12D and 11F. All right, so 11F. All right. 11F. Swati runs a small business. She used a straight line depreciation model of 20% of the original price per annum to depreciate the cost of her office desk originally valued at $1850. Construct a function to represent the value of Y of the furniture after X years and state the domain and range of this function. All right, again, I'll give you guys a few minutes to maybe interpret those words. Good news is it does tell you it's a straight line depreciation. That means you should be thinking of this. And it depreciates, that's going to be my clue. Okay, so if you use a straight line depreciation model of 20% of the original price per annum to depreciate the cost of the office originally valued at 1850. So if you want to think of this graphically, you would have started off at a Y value, represent the value of the furniture after, X is in years, Y is the value that it started with. It would have started with 1850, right? You know that. And then every year it loses 20%. So what is 20% of 1850? Well, 20% of 1850 gives you 370. 20% of 1850 equals 370. Yep. Then you're going to lose 20% of that, which becomes 296 and so on. So 370, and then that means your new value is, just so you guys can visualize this if you want to see it, that's 1580 after 1 year. So that's at 0. After 1, it's at 1580. After 2, it's somewhere a little bit less, and so on. All right, so we need an actual function. Well, you know the y-intercept is 1850, so y equals plus b, we'll do that as 1850. We know it's losing 20%, so minus 20% of, what do we think now? Anyone have any ideas? Actually, 20% of I would have just done it as 1850 times 80%. That's what I would have done. So how am I going to show it to you guys? 1850 minus 20% of 1850. No. Minus 20% times n of 1850. Nope, I don't like that.
Yeah.
Sorry?
Where did you get 1580 from?
Where did I get 1580? That number?
Yeah.
Well, I was just trying to show you that if you're losing 20% every year, after 1 year, what's 20% of 1850? That means you lost 370 bucks. Or 370. Yeah, 370. Right? And then you subtract 1850, take away 370. That gives you 1580.
Doesn't it give you 14?
What did you get?
14.
Let me see. Oh, 1480. Yep, thanks. That's better. All right. So, look, I know what my function is. I'm just trying to do it this way, but I can't seem to get it out without doing it like this. 1850, 1 minus 20%, which is 80% of n, right? 1850, let me just check it. 1850 times n is 1, 80%, which is 1480. 1480 times 20%. No, it is 20% of the original value. Oh my God, that's why it was meant to be easy. Sorry, go back. So you're losing $370 every year. Losing $370 every year. So yeah, like I said, your y-intercept is 1850. You're losing $370 every year. So every x. When x is 1, it should give you 1480. When x is 2, give you a little bit less. X is 3, and so on. It's not 20% of the new price. It's not 20% of 1480 and so on. That would be compound interest, not straight line. Which is where I was mixing it up in my own head. Aya, does that make sense what I've done there?
Yeah, that makes sense.
So you're losing 370, that's why it's a straight line. You're losing 370 every year. And then of course, state the domain and range. That's quite simple. The range is, well, it looks quite simple because I guess if you had that line, you would have said just all real x and all real y. But we know that for a particular case, it's not the situation. I mean, it's applied, right? So the domain, you can't have x years being less than 0. So domain is x. I'll get to that. Range, we know that should be, okay. All right, so obviously this will eventually hit 0 here. So my range is going to be from 0 to 1850. 0 to 1850. We're all okay with that? That's my y value, or y is between 1850 and 0. It can be 0, so it can become nothing. When does it become nothing? 0 equals 1850 minus 370x. Solve for x. It should be 5. Right? Yep. X should equal to 5. So your domain is not, I was going to write x is greater than 0, and then I paused. X is between 0 and 5 only. It doesn't, like after that, you'll have a line, but that's because you depreciate, the value of the thing is going to negatives, which just doesn't make sense. I like that. I like that question because it's such a simple, basic question, but like that bit there. But then with the domain and range, you've got to be very, very careful that you're applying it to that applied question, not to this equation. All right. I want to ask it again. Any questions about what I've done? Maybe repeat something.
Wait, sorry, just to clarify.
Yes.
So for the second part, instead of subbing, so you just solve for x basically of the equation we found?
Say that again. I've got y equals 1850 minus 370x.
Yeah, so for the second part, for the domain
And I'm
part,
trying to find the domain and range, and I know that I can't get to like negatives, of course. So I'm
yeah,
trying to find when y is 0. I found that when y is 0, x is 5.
yeah,
And then in the same token, I'm trying to find out when y is 0, when x is 0 when y is 1850, as we already know.
yeah. And then,
We know that the smallest y values are 0 to 1850. I mean, smallest and largest, and the smallest x's are from 0 to, and the largest is 5.
yeah.
And that's it. That's your domain, and that's your range. Yep, good. Okay. Question 11, question 12, D and B, B and D. And we just did that one, and that's it. That's all of year 11 from 2017. So question 12, B and D. All right. 3D trig. Oh yeah, that's a good one. 3D trig. All right, let's do this one first. You can see from just doing all of this, year 11 topics, I mean, some are easy, some are a little bit harder. The problem with year 11 is there was a lot of disparity between topics. So a lot of things were just all over the place, whereas in year 12, when calculus gets introduced, everything's all calculus based. It makes it a little bit easier. So it's usually year 11 that's a problem. All right, let's do this. For events A and B, the probability of A and B equals P. Probability of A and B equals P. Probability of A naught and B equals 2P minus a quarter. Probability of A and not B equals P on 3. Given that A and B are independent, find the value of P. Independent, what did we say again? What did we say with independent? Can someone remind me with independent, if they know it? No? Just we didn't get it wrong. You guys should be pretty familiar with these by now. Independent. All right, A and B is equal to A times B. All right, probability of A and B. And if you want to see the others, so probability of A and B equals probability of A times probability of B. The ones that are helpful as well, maybe that one there. Probability of A equals probability of A and B plus probability of A and not B. Those ones are always helpful. I'm probably using it in this one anyways. All right, independent, that means probability of A and B equals probability of A times probability of B. And as I just wrote, probability of A equals probability of A and B plus probability of A and not B. Okay, so what do we have? We have, all right, well, we know that probability of A, so let's call this equation 1, equation 2, from what we know. From 1, probability of A and B equals P. Probability of A equals probability of A and B plus probability of A and not B, so that's P plus P over 3. And probability of B, same formula, it would be P plus B and not A, so P plus 2P minus a quarter. So probability of B would be probability of A and B plus probability of not A but B. I'll pause there. Just let all of that sink in for a second. I am going to select you again. You're going to tell me if yes, this is fine. Given that you have studied and you've memorized these, or you've understood these by now, it's either one or the other.
Sorry, Sam, can you say that all again? My dogs just ran in.
Yep.
Sorry.
If they're independent,
Yes.
this occurs. Probability of A and B is equal to probability of A times probability of B.
Mm-hmm.
And then the one formula that's not taught that is very helpful is this one here, which just, you can either do it logically or you can just learn it now. Probability of A is where A and B meet and where A is by itself and not B. Do you want me to show you this on a Venn diagram?
Haven't we done that?
Yeah.
Yeah,
So
I think I.
so you
Yeah.
know that? But
Yeah.
I'll just show it real quick here. So imagine the weird big circle here on the right is A. It's saying to find A, it would be this bit here, and the bit that is A but not B, which is this bit here.
Yeah.
Which is of course right. That is, the whole thing is A.
Yeah.
So yeah, that's all it says. But it's just, you know, you guys will see it like that, so you need to be aware of it like that as well. All right, and then same thing with B, you could have said the same thing. And then I just put it in. Probability of A and B is P. Probability of A is P plus P over 3. And then probability of B is P plus 2P minus a quarter. So you agree with that as well?
Yeah, that makes sense.
And then again, from 1, we're going to, that's from 1, that's from 2. And then from 1, from 2, and then pretty much put it all together. So P equals PA times PB. P equals P plus P over 3 times P plus 2P, which is 3P minus a quarter. You know what you've got to do, just expand, simplify, start solving for P.
Mm-hmm.
I'll leave it with you guys for a minute again, try it out. All right, here we go. P equals, I personally would have made this as 4P on 3, but if some of you haven't done that, I'm just going to expand it accordingly. For those who did make this 4P over 3, it would have made it a little bit easier. It doesn't matter. 3P squared minus P over 4 plus 3P squared over 3 minus P over 12. 3P squared plus P squared is 4P squared minus p over 4 minus p over 12 is minus a quarter minus 1 over 12. Plug it into your calculator, should give you a third, so p over 3. Bring this over. Minus a third minus 1 is minus 4p over 3. Factorize. So p equals to 0, which doesn't make sense, or 4p equals to 4 over 3, which means p equals to 4 over 12, which is 1 over 3. That should be the answer. Questions? Rosemary, questions? Any questions there? Tiana?
No.
No?
No.
Okay. Moving on. Are you okay with it?
Yeah.
No, moving. I think the last one was the trick. An 8-meter high vertical flagpole, ST, is situated on flat ground. The angle of elevation from A to the top of the tower is 30. The angle of elevation from B to the top tower is 45. B is south of the tower and A is west. B is south and A is west. Find the distance from A to B. All right, easy. Easy, easy, easy. If that's south and that's west, this is a right angle. The way we did these styles of questions was to always work out the bottom triangle. So the first thing I'm going to do is find TB. And the way we did it was always through tan. So opposite over adjacent. Tan 45 equals 8 over TB. That means TB equals 8 over tan 45. Do the same thing for TA. Tan 30 equals opposite over adjacent. Therefore TA equals 8 over tan 30. But because we know now that this is a right angle triangle, you won't need to do cosine rule, you're just going to do Pythagoras. Right? Right angle triangle, you'll just do Pythagoras for that. So AB squared equals TB squared plus TA squared. Therefore, AB equals square root of that. I'll just get an answer out. Tan 45 squared plus 8 on tan 30 squared. And that becomes 256. Square root it. Apparently the answer is 16. Any questions there? No? Okay. All right. That's fine. Okay. Do you guys want to keep doing your 11 questions? Aya, what do you reckon? More year 11?
Yeah, I reckon.
Yeah, just finish off year 11 maybe today. Okay. I'll send you the solutions if I haven't. I think I did. I sent you the solutions to that Year 12, yeah, I've already sent you the solutions to the Year 12 booklet I just sent you guys. So if you work through it, maybe tomorrow morning or whatever, in tomorrow's class we can go through the Year 12 questions. All right, let's do the 2018. All right. I'm going to skip the basic questions now, like this. What is the x-intercept? And just move straight to some of the more difficult style ones. All right, question 6. A runner has 4 different pairs of shoes. If 2 shoes are selected at random, what is probably there will be a matching pair? Well, it has 4 different pairs of shoes. So, what are we thinking? Let's call them, like, I mean, you can say that there's 2 reds, 2 blue, 2 green, and 2 yellow shoes. 2 shoes are selected, and there will be a matching pair. So what's the probability there would have been 2 red, or 2 blue, or 2 green, or 2 yellow? Give me the math. I can give you a clue. It's 4 times, obviously them being the same. So pick. What would be the math? Come on. Tiana, you want to give it a shot?
Would it be 4 times 2 on 8?
2 on 8. Oh, good try. No. Angie, what about you?
Yeah.
Any ideas?
Isn't it just 1 on 7?
Isn't it just 1 on 7? Is that what you said?
Yeah.
What's your reason?
Or you pick 1 shoe, then there's 7 left, so you have a 1 in 7 chance of being a matching pair.
Good point, actually. Maybe. I see what you've done. Select a shoe and there's a 1 out of 7 chance that's a matching pair. Yes. Why was I thinking differently? What is the probability that there will be a matching pair? 4 times. The first one's going to be red. Let's see if it would have made a difference. My math would have been, first one's got to be, let's just say red. So then that would be a 1 out of 8 chance. No, red. And 2 out of 8 chance times, and then I would have had the second one has to be a red. Oh, wait. May have confused me with your thought process. 1 out of 8 times, it's going to be red, and then the first one's going to be red. The first one's going to be red, or 2 out of 8 chance, and the second one has to be red. 1 out of 7, so 2 out of 8, and a 1 out of 7. And in my case, the answer looks like it becomes what? Oh, it's still 1 out of 7. Yeah, it's still 1 out of 7. But I like your thinking. Probably would have been a little bit faster. That's okay. Same answer. I'm going to go about it this way, but I like what you did as well, Andy. Just because I guess this is a bit more consistent with the way we were already doing the questions. All right. What is probably that there will be a matching pair? So, like I said, 4 different colors. Let's just say we chose red. What's the probability of getting red in the first shoe? That would be 2 out of 8 times. What's the probability of getting a red shoe in when there's only 7 left? Obviously, you've chosen 1 red, so that's gone. It'll be 1 out of 7. When you expand this, the answer is still 1 out of 7. Otherwise, Andy's thought process was, well, just choose 1 shoe. Doesn't matter which one you choose. And then you've only got a 1 out of 7. Like if it was yellow, let's say, you've only got a 1 out of 7 choice of being able to choose that yellow such that it become a matching pair. So, also true. I like it. I guess it's not the way I usually think, but I do like that thinking. It's more efficient anyways. Are we okay with that? With this method or Andy's method? Yep, we're happy. Cool. Next one, 2018, question 3, don't got that. 6, we're done. All right, we're up to 13, 12, 11, 11A, 11C. You can see already this year, in 2018, they didn't have many year 11 questions in the multiple choice this time. Oh, well, it works like that, right? All right, that's out of the syllabus. I don't know why that's still there. I think they did that wrong. That's meant to be a cross. That's still in. That's okay. We can fix it up. That's gone. All right, solve. 1 minus 3x greater than 10. Easy. Negative 3x is greater than 9. X is less than negative 3. That's straightforward. Evaluate, differentiate, differentiate. All right, we'll do this one. Question 12. 11A, 11C. Yep, we're up to 12. Okay. 12. A ship travels from port A on a bearing of 50 degrees for 320 kilometers. We know what I'm going to do before I continue. Just put that in. That's 90, so that's 30. This is 50. This is 60. If that's 50, then we know that's 50. Already we know that's 110. And that's about it. That's it for now. It then travels on a bearing of 120 for 190, and then maybe if you really wanted to, also do one there. Okay, what is the size of ABC? ABC, already done. What is the distance from port A to port C? X. That's cosine rule. So x equals square root of 320 squared plus 190 squared minus 2 times 320 times 190 times cos 110. Easy. So the nearest 10 kilometers, there's an easy loss of a mark. Don't become complacent. Make sure you get that out. I'm just trying to get the answer out for you guys now. Square root that. 424, nearest 10 kilometers becomes 420 kilometers. Round it down. Okay, any questions there? Right. I don't think we need to copy that one down. That's a fairly straightforward one. Alright, 12A we just did, 12D, fine, we'll do that now. 13C, 12, okay, 12D. The displacement of the particle is given by this, where x is displacement from the origin. What is the initial velocity of the particle? Well, V equals 3t squared on 3 minus 4t plus 3. And initially, you'll just sub in t equals to 0, which means initially. V equals 3. At what times is the particle stationary? Just make V equal to 0 this time. So that would be when t minus 3 and t minus 1. So at 3 and at 1. And then find the position of the particle when the acceleration is 0. Be careful, you're finding position. So acceleration equals 2t minus 4 equals 0. Acceleration is 0. Time 4 divided by 2 is 2. Does not ask you to find the time, it asks you to find the position. Therefore, x equals 2 cubed on 3 minus 2 squared plus 3 times 2 is 6. That's it. Any questions there? All right. Moving on. Okay. Moving on. 13C is the next one. Oh, this one's relatively good. The population of a country grew exponentially between 1910 and 2010. Population of a country is 1960. In 1960 was, okay, obviously that's when T equals to 50 years, P equals 184 mil. Show the value of K is this. All right, you're just going to sub it in. So for I, it's 184. Equals 92. It already says PT is already in millions, so you don't need to sub in a million. Be careful. 92 E to the K T, so 50K. And just let me know if you need me to show you how to find K from here. Please. No, we're all comfortable with that. Just double check it on your calculator. Then should be something along those lines. Okay, double I. Assuming that this model continues to be valid after 2010, estimate the population of the country in 2020 to the nearest million. Okay, that's easy. That was 100 years. So now you're doing it for 110 years, right? That was 100 years. You're just doing it for 110 years. So very easy. The population equals 92 E K times 110. Again, the only place you could really go wrong is nearest million. Just be careful with that. I don't think we need to go through that. That's all I can say. Just be careful. You got to think about, have you reached, you know, in 2020, have you got to that particular population that you're going to round to? Again, let me know if you want me to do it. Otherwise, I'm going to look at the next one. So just let me know. 14A, 14E. Anyone have questions about this one? Nope. All right. 14A, trig. Okay. In triangle KLM, KL has length 3, LM has length 6, KLM is 60 degrees. The point N is chosen so that on side KM so that LN bisects angle KLM. The length LN is also X. Okay, find the exact value of the area of triangle KLM. KLM. All right, what's the area of a triangle? See now, second paper. You should be pretty comfortable with the area of a triangle. This time, half A, B, sine C. Sine 60 is root 3 on 2. And then, of course, simplify it. So the answer is, 6 times 3 is 18. 18 root 3 on 4, root on 4, which becomes 9 root 3 on 2. Any questions? Hence or otherwise, find the exact value of x. Okay. Can somebody give me any idea of what they're going to do? What do you think they're hinting at to you? They're trying to hint something by, obviously, I don't know, giving you that and then giving you the hands. What are they hinting at for you to do in double I?
Use part I.
Yes, how? Can you tell me?
Use the area you found minus one of the triangles area.
Did you say minus?
Yeah.
Yeah, yes. Yeah, I guess so. Area of the big, yeah, but wait, hold on. Did you say the area of the big one minus one of the areas, right?
Yeah.
But then what is that? What are you going to make that equal to?
The other triangle.
Okay, fine. Yes. So in other words, you picked it up, well done. In other words, what it's trying to tell you is the summation of this plus this needs to give you the whole thing. And that's the way I would have approached it. So the area of the whole KLM is equal to KLM plus NLM. So the area of the small, area of the medium gives you the area of the large. Or you could have done what Andy said, large minus medium gives you small or whatever. But I mean, the other approach is probably a bit more logical. Good, well done. Half times 3 times x times sine 30 plus half times 6 times x times sine 30 needs to give me 9 root 3 on 2. Sine 30 is a half. Half times a half is a quarter times 3, so that becomes 3x on 4 plus, that's a half. Half of 6 is 3, 3x on 2. And then, of course, just add them. 3/4 plus 1.5, 3/4 plus 3/2 is 9x. Pretty much get rid of the 9, or you could divide by 9, times it by 4, x equals 2 root 3. Again, the math is easy, right? To do that stuff is easy. It's just knowing at the beginning, oh yeah, I see how they gave me the whole area and they're trying to tell me to split it up. Don't get so caught on the whole bisecting and stuff like that. Good. Questions? All right. What question was that? That was question 14A. E and B. 14E and 16B. 14E and 16B. 14B. 16B. Both probability. All right, let's do E first. So read. Two machines, A and B, produce pens. It is known that 10% of the pens produced by machine A are faulty and that 5% of the pens produced by machine B are faulty. One pen is chosen at random from each machine. What is probably that at least one of the pens is faulty? Okay, again, at least one of the pens is faulty. 10% of the pens produced in machine A are faulty and 5% from each machine. Well, so machine A, and then there's B. For machine A to be faulty, so it could be like this, faulty and not faulty. It could be faulty and faulty. It could be not faulty and faulty. Or, that's at least one of the pens is faulty. Or, you could have done it as 1 minus, both of them not faulty, not faulty. True? That's what we did before with the at least. So it would be 1 minus, not faulty for machine A. Machine A not to be faulty is 0.9 times. Machine B to not be faulty is 0.95. So that's 0.145. Okay, we're right with that. Double line. A coin is tossed to select one of the two machines. Two pens are chosen at random from the selected machine. Whereas probably that neither pen is faulty. Okay, a coin is tossed to select one of the two machines. All right. So let's just say that's for heads, and that's tails. And let's say heads was for machine A and tails was for machine B. So a coin is tossed to select one of the two machines. So if you've got heads, you get A. Doesn't really matter. You could have done heads at B. Doesn't matter. So let's just say it was A. So if you got A, that means you must have at least got heads, which is half. Then two pens are chosen at random from the selected machine. So now you're at A, and two pens are chosen. What's wrong with that? Neither pen is faulty. So half, then times, neither pen is to be faulty. That means, yeah, so pen A is 0.9. And then again, the second pen is also 0.9 because you're in machine A still. Or it would have been machine B. And then 0.95 times 0.95. Do we understand my logic there? Maybe do we even agree with my answer? Andy, let's check since you're looking like you're good with probability. You agree?
Yeah.
That's good. So first, a coin is tossed to select one of the two machines, full stop. I did that. I went H for A and T for B. It doesn't really matter like I said because they're both half. And then if you chose A, you want neither pen to be faulty. So pen 1, not faulty. Pen 2, not faulty. Or B, pen 1, not faulty. Pen 2, not faulty. Okay. Moving on. Okay. A game involves rolling 2 6-sided dice, followed by rolling a third 6-sided die. A game involves rolling 2 6-sided dice, followed by rolling a third 6-sided die. To win the game, the number rolled on the third die must lie between the 2 numbers rolled previously. For example, if the first 2 dice show a 1 and a 4, the game can only be won by rolling a 2 or 3 with the third die. Fair enough. What is the probability that a player has no chance of winning before rolling the third die? Okay, so let's play the game as always. What is the probability that a player has no chance of winning? Okay. So let's just list them out real quick. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then all the numbers are 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. I think we get the idea. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. I want to be faster now, as fast as I can. Okay, then for you to have a chance of winning to have a chance of winning, what needs to happen is you need to have a number where you can get a number in between. So you need to get numbers where you can get numbers that are between. Obviously, like this, 1 and 4, that can work. 1 and 5 can work, 1 and 6 can work. Let's say 2 and 6 can work, but then by the time you get to 5 and 6, that can't work. 5 and 6 can't work because there are no numbers between 5 and 6 that also lie in the die. So, what is the probability that a player has no chance of winning before rolling the third die? Well, that should be pretty much all of this. So, all of this. There we go. And then obviously how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 out of 36. Did I miss any? In case I did. Doesn't look like it. Yep, I'm happy with that. All good? That makes sense? What is the probability that a player wins the game? So, what needs to happen for you to win the game? Aya, can you tell me the situation where you will be able to win the game?
Just be 1 minus.
Wait, I can't hear you very well. Say it again.
Can't it just be 1 minus what you just worked out?
Nah, not exactly. Because you're saying it's just one less. One less than what I just wrote down will get me the possibility of playing the third round. But when I come to the third round, don't I have to roll dice again? So like imagine I did this in my first round, right? This is my first round.
Mm-hmm.
But in my second round, I must get a 2, 3, 4, or 5. What if I get a 6? Do I win?
No.
No. So that needs to be taken into account. Does that make sense?
Okay.
Yeah, exactly. So it's not just 1 minus. 1 minus gives you the opportunity to enter round 3.
Oh, okay.
That's how you got to interpret that.
Mm.
So once you're in round 3, you've got to think about now, okay, I'm in round 3, great, I'm there. Now to win my game, I need to see like all the ones that have, one number between, two numbers between, three numbers between, and so on. I don't think you can, yeah, we're going to have four numbers between, 2, 3, 4, 5. Yeah, four numbers between. So, for example, if I had four numbers between them, it would be this and this. That's the only case where there's going to be four numbers between them.
Mm-hmm.
Yep.
Yeah.
So firstly, for me to even enter into that place, I had to get a 2 out of 36. So 2 out of 36. And then for me to win in my third round, I had to get a 2, a 3, a 4, or a 5, which is a 4 out of 6.
Yeah.
Does that make sense?
Yeah, then.
And then plus, now I'm going to do three numbers between. Three numbers between would be 2, 3, 4. This one, 3, 4, 5. So then that'll be 5 and 1, 6 and 2. Any other ones? I don't think so. So that should be 4 out of 36 times, and then there's three numbers in between, so 3 out of 6.
Mm-hmm.
Get the idea? Yeah.
Yeah.
Plus, of course, there should be now two numbers in between. Two numbers in between, there should be, I think we're seeing a pattern, 2, 4, 6. But let's have a look. 2 and 3, 3 and 4, 4 and 5. And then same thing with here. 2 and 3, 3 and 4, 4 and 5. So 6 out of 36 times, and then two numbers in between. And then last one, grey, 8 out of 36, and then times 1 out of 6. It is a question 16, so last question of the paper, so it's a little bit trickier. Got to think a little bit more. But I'm sure you agree with it. I know now that I've explained it, but you've got to really put yourself in that situation. You're like, right, for me to get to the third game, I had to have first, got something that was possible. And those are all the possible cases. And then for me to win the third game, I also need to get those particular numbers.
Yeah.
So the idea is you've got a greater chance, as you can see this one in grey, you've got a greater chance of getting, these ones here. So 8 out of 36 chance. That's a pretty good chance. But then you've got a very bad chance in your third one. You've got a 1 out of 6 chance of actually winning. Because there's less numbers, right? There's only one number. Like here, you've got to get a 2. Have to. Here, you have to get a 3. Have to get a 4. Have to get a 5. Cool? Any questions? Yes? No? Any questions from anyone? Okay. Very good. I think we've got the replacement questions left. So.
Wait, I'm sorry, I didn't get a chance to get that question down.
Yep, that's fine. Yeah, I'll go back. You want to write? You were writing it down?
Yeah, I'll just take a photo. Thank you.
All good?
Yeah.
Okay. Question 1. All right, let's go. Let f and g be two functions such that f of 3 is 2, f of 5 is 3, g of 2 is 3, g of 4 is 5. What is the value of f of g of 4? Okay, well, f of, yeah, I like that they were trying to be confusing. G of 4 equals to 5, so you're just trying to find f of 5, but f of 5 is equal to 3, so the answer is 3. All good. They tried. No, all good. Any questions? Okay. This one. The rule for a function with this graph above. Remember, whole polynomial, even, odd, and then negative odd, and then negative even. And then pretty much intercepts, powers of ones, powers of twos are bouncy or parabolic. Okay, let me think as well while you guys think. If it starts up here, it's either going to be a negative odd or an even. So these all look like they're going to become, oh, that one, that's an odd, but that's not negative, so that one's definitely wrong. Okay, so we're tossing up between these, but then that is an even, but then times by negative, that's also wrong. So now we're tossing up between these two, and then it should be at negative, so that's A, which is all the way here, that's minus A, positive B, positive C. Wait, what? Other way around. That one. That's really minus A. Equals A. But anyways. Minus 2x plus A, x minus B, x minus C. That's 0. It's okay. Actually, good point. Hold on. That's 0 and that's A. Yeah, still has to be x plus A. If A is negative, it's like negative 5, it will still be x. No, hold on. If A is positive, but really should have been negative, then it should be x minus A, so it becomes plus. No. I'm actually going to override it and say it's B. Can anyone tell me why I was tossing up between these two? Why was I tossing up between these two, going back and forth? What's the issue? Rosie, what are you thinking? What was I contemplating?
I'm not sure.
At all? Would you have gone for C?
Yeah.
Okay. Tiana, what about you?
I still would have gone for C.
Gone for C as well? No problems. Rad? Andy?
Isn't it C?
You reckon it's C as well?
Is it the intercept?
It shouldn't be C. So here we go. Now look, this is saying A, B, and C, right? And we know that 0 is there. We know that 0 is there. So B and C are positive numbers. We definitely know that and we agree with that. So therefore, if they're positive, we need to go back. So therefore, let me just show you an example. X equals to B. X equals to C. So therefore, we're going to go back, which we get X minus B, X minus C, which is exactly as we know it should be. And I think we don't have a problem with that. Now, usually, anything below 0 is negative. Right? So therefore, it's been like -5 or -4 So therefore, when x equals to -5, we get x plus 5, x plus 4. True? And that's why you guys are saying it should have been C. The thing is, they didn't give you A as negative A. It doesn't say that. He actually left it as A, which means x equals to A. So therefore, when you go back, x is still x minus A. Now, the A value is negative. So let's just assume A was -5, right? It is negative. So when it is a -5, you can see from my expression, that does give you x plus 5 as you know it to be. And that's what you guys are thinking. You're thinking it should have been x plus A. That's because obviously usually on the left side it's been pluses. But what you've got to understand is actually A is A. It's not saying it's negative, so we're not plussing it to the other side to make it a positive. It is a negative, which is fine, but then A is also negative, so two negatives will keep it a positive. So it works. It's not that it won't work. The answer is actually a B, not C. Does that make sense now, Rosie?
Yeah, but I would have put C.
I know, but that's why we're studying, right? And that's why we're practicing. I know, it's fine. You even saw me. I was tossing up between B and C, and I went, oh, I get what you're trying to say there. A is not actually -5. It doesn't say that. It doesn't say A is negative. Like, it doesn't say nothing for it. It's just A. So if it's A, all you have to say is it's x minus A. Okay. Okay. Sneaky. Very sneaky. But that's what they can do with multiple choice. Right? They can be annoying like that. Okay. Question 4. For the random variable, it is known that EX is 2.6. The expected value squared is 8.4. Okay, easy. Well, we just did that one. Variance of X. We already know that's the same as EX squared minus EX squared. EX squared is 8.4 minus 2.6 squared. 8.4 minus 2.6 squared. And then standard deviation equals square root of that. Easy one, Marcus. Any questions there? Okay. I think that's part of logs. Let me see if that's year 11. Question 8. Yep, question 8. Alright, let's read. On the Richter scale, the magnitude R of an earthquake of intensity I is given by this formula. R, where I0 is the reference intensity used for comparisons. The 1989 Newcastle earthquake measured a magnitude of 5.6 on the Richter scale. Which of these is closest to I over I0, which is the number of times the earthquake is more intense than the reference intensity? On the Richter scale, the magnitude R of an earthquake of intensity I is given by this formula. Reference to the comparison. The 1989 Newcastle earthquake measured a magnitude of 5.6 on the Richter scale. So R equals to 5.6 equals to ln of I on I0 on ln of 10 times it by 5.6 So that becomes 5.6 log 10 equals to log I over I naught. Bring the 5.6 up, that becomes log 10 to the power of 5.6. That's 10 to the 5.6. 10 to the 5.6 is about 398,107. So it's looking about 400,000 times. That's the closest. Any questions there? Nope. Just making I over I naught the subject. Question 11b. Will that be part of your 11? And 18, yes it is. That's the last one. No, 12c and 14b. Okay. So C and okay. All right. Let's start with this one. Part of rates of change. The volume V of gas varies inversely to the pressure of P. Okay, yes. Volume V, okay, so V is inversely proportional to P. So that means K on P. Volume equals K over P. Volume of gas is 160, so V equals to 160. Pressure is 36. K on 36. So the first step with these questions, you have to find K. So K equals to 160 times 36. 5760. So your new formula becomes V equals 5760 over P. Then the question will just say, what is the volume when it's 48? Very easy, you just sub it in now. 120 centimeters cubed. That is very poorly done. I know in general it's very, very poorly done because it's very small little dot points in the syllabus. So I would be doing that again and again until that's memorized. So when you see it inversely, you know that it's K over P, like that. And yeah. Okay. If there's no questions, I'm going to move on to C. The probability distribution of a discrete random variable is given by this. Show that P is this or this. I think we already know how to do these styles of questions. We do 0.1 plus 0.6 P squared plus 0.3 plus 1 minus P. So the addition of the bottom must equal to 1. And then I'm just going to write quadratic formula if you wanted to, and then you should end up with that. Question says, let P equals to 2/3, find correct expected value of X. Remember, expected value of X is 0 times 0.1 plus 1 times 0.6 P squared, where P is 2/3, not squared, yeah, sorry, 0.6 P squared, yes, plus 2 times 0.3 plus 3 times 1 minus 2/3, which is 1/3, of course. Everyone's okay with that? And we need an answer so we can do the second part. Okay, so give me a second. plus 0.6 plus 3 times a third. 1.87. And then beta, find the probability such that x is less than or equal to 1.87. Because this is not continuous, so for those in extension 1, be careful not to do it like continuous, it's just discrete. So if it's less than 1.87, that means it had to be probability of x being 0 and probability of x being 1. So less than 1.87, less than the mean, is just these two. So what's the probability of 0? That's 0.1. What's the probability of 1? That's 0.6, 2 over 3 squared. So probability of 0, 0.1, and then probability of 1. And that should be less than 1.87. Well, you can't get 1.87, it's going to be less than or equal to 1, technically, so 1 and 0. Does that make sense? Tiana, does that make sense?
Yeah.
Yep. Okay. Scrolling down. Last one. For events A and B from a sample space, probability of A conditional to B is a quarter, probability of B conditional on A is a third, let probability of A and B equal to B, find B in terms of OK. So again, just put in all the formulas you know. So probability of A conditional to B is probability of A and B over probability of B. Probability of B conditional to A is still probability of A and B over probability of A though. Okay, well what do we know? We know A conditional to B is a quarter. We know A and B, probability of A and B is equal to P. So cross multiply, and then you just get probability of B is equal to 4P. That's I done. Find probability of B in terms of P. Done. Double A. Let's do double A P. Double A. All right. Probability of not A and not B. Probability of not A and sorry, not B and not A. Not B and not A is equal to one probability of A and B. No. What am I thinking? Probability of B, not B, not B, not B and not A. That can be in the middle. Probability of B, not B, not A. 1 minus okay. 1 minus A or B. One minus probability of A or B. So, not B, not A, the whole thing, of course, 1 minus A or B. So, you get that little bit in there, and you get the outside, which is exactly what it should be. Okay. All right, A or B, probability of A and B is equal to probability of A plus probability of B minus probability of A, well, hold on, other way around. Probability of A or B is equal to probability of A plus probability of B minus probability of A and B. Probability of A, we haven't found. The probability of B we know is 4p. Probability of A and B, we already know that's p from the question. So the only thing that we really need to find is probability of A. So probability of A, using the formula that we wrote here, we know that probability of B conditional to A is a third. So that becomes 1/3 this time, equals probability of A and B, which is P, over probability of A. From that, we end up with probability of A equal to 3p, equals 3p. 7 minus 1 is 6. And the answer for probability of not B and not A is equal to 1 minus 6p. Please be familiar with all of these formulas. You know you're going to get in your exam. The worst thing you can do is not memorize them all. If you want these little notes that I've made here, it's just 2 pages long. I can send it to you. I don't mind.